Hello everyone, the title of our project is called Milk a Cow in Minecraft. Well, Minecraft is an open world exploration game where everything in the world is based on blocks. It also allows players to craft tools, explore, and achieve various milestones in open-ended and creative manner. It's easy to quantify nature also makes it an excellent choice for researchers to build agents that complete different tasks in a relatively controllable environment. And in our project, we're going to build a reinforced agent that milk a cow. Let me explain. Let me start off with motivations. Minecraft provides a complex yet controllable dynamic environment. Dynamics because when the world is being generated, not everything is static. Every time there will be some variation such as moving objects and the auto-generated terrain is going to be different. Also, the agent is getting information just like human agent would do, and they will control the game as if it was a human agent holding a controller. There's many ways we can interpret of saying milking a cow. It can be varied by the initial world settings, if the agent is spawned with a bucket, or if it's spawned in a cow biome. If it's being spawned in a flat world, meaning everything's leveled and the agent will not need to learn how to walk properly. And versus in a default world, it has to learn how to traverse the terrain properly and explore things and get over blocks. And making the bucket itself is actually very hard because you have to make a pickaxe, mine the iron ore, smelt it into iron ingots, then finally make the bucket in the crafting table. And the last is a cow biome. If there's no cow in where you spawned it, the agent will be having a very hard time to get positive rewards. So in our setting, we will have a default world, meaning the agents should learn how to traverse the world, and it will be spawned with at least one bucket, and there will be cows nearby. Now let's talk about insights. We're using a Minecraft environment called MineDojo, which allows us to interact with Minecraft world with Python. As we just talked about, reward can be very interesting that we can modify. By default, MineDojo provides a very simple reward function for milking a cow. It gives 0 if there's no milk in the inventory, and it gives 1 at the last step if the agent is able to obtain milk in their inventory, which obviously is a very sparse reward function, which we hypothesize that it would not guide the agent to do such complex tasks such as goes through the terrain and find a cow, then milks a cow. The second one we want to talk about is exploration encouragement. It is likely that the agent will stuck in some sort of false convergence that prevents it to try other actions because the probability of one action set is going to be approximately 1. Let's talk about the setup. We have simplified the observation space and action space from MineDojo that get rid of the actions that we are not going to be used, such as drop, such as attack. We have created a custom hybrid type policy net that takes in both the RGB images and other discrete data set that combine them into a multi-dimensional action probability vector. And we implement a reinforced algorithm with reward to go with policy gradient to calculate the loss function. So from the insect session, we talked about reward shaping and exploration encouragement. For reward shaping, we noticed that agents were not able to approach a cow. So we used the LiDAR function, which gives the distance between the agent and cow in Minecraft Dojo to build a more dense reward function. We implemented it such a way that the agent is able to get higher and higher reward when it's approaching the cow, but it gets no reward when it's moving away from the cow, even though they're close. As a result, we found that the agent is able to look at the cow and approach the cow properly. Next, we want to talk about exploration encouragement. Initially, we found the agent, after a few iterations of training, that it only able to look up the sky or look at the ground, because the probability of doing so is just 1. We approach it through 2 solutions. One is to use the softmax function that smooths out the distribution inside each action set. The other we implement is epsilon greedy. So in our policy net, there will be a probability of epsilon that the action probability distribution is fully rendered. This gives the agent ways to explore action that is independent of the state of the neural network. As a result, we find the agent is no longer stuck into some sort of weird camera angle and able to explore the world properly. Due to some known issue with MineDojo library, we have to modify its source code to ensure its compatibility with its dependency. This modification made it hard to train the code set on the cloud, and since the policy neural network is very complex, it is needed for a lot of computing power to be spent on training. However, we did achieve some promising preliminary without using an M1 MacBook Pro, As you can see, this is the result from training the agent from 50,000 Minecraft time steps. The agent is able to look around the environment and look on the cows, and finally able to lock in on the closest cow and use the use button to collect the milk. And finally, the few takeaways we want to give is the dance reward function will guide agents in complex text, especially consists of many subtasks such as walking and exploring. Furthermore, exploration encouragement is also very important that prevents the agent to stuck in some sort of weird convergence that gives probability of 1 for some actions. Thanks for watching.